Greetings and welcome, friends. Mr. Wadi here. Today we are continuing to graph quadratic equations, which are parabolas as graphs. And today we're going to be talking of what about when you put an a, some number besides 1, in front of your squared term. And so here you go. You can see some of these. When a is equal to 1, you get this orange graph, like so. That's the regular up 1 over 1, up 3 over 1, up 5 over 1. When a is bigger than 1, it's a vertical stretch, right? Vertical stretch of the graph. And this is interesting. When a is between 0 and 1, it's a vert smoosh. Ooh, sneezes. Wow. All right, so smoosh versus stretch. Like so, right? And we've seen kind of some of those when we were graphing absolute value equations. Much the same principle applied. It's just this time instead of a V, we've got a parabola. It also says that when a is less than 1, all it does is a vertical flip. So a reflection over the x-axis is what happens there. All right, or I might describe that as a vert flip, which is also some of the language I use when me and Tony Hawk are hanging out. I'm like, hey, check out this vert flip of my parabola, Tony Hawk. And he's like, Mr. Wadi, that's amazing. And I'm like, yeah, I know. You're jealous. Oh, no. He's like super impressed with my graphing of parabolas. And actually, I wonder... No, I was just wondering about the shape of skateboard ramps. Those are probably more semicircles than they are U-shapes or parabolas, I'm guessing. I don't know. Oh, this is like a person you know. Like, not like a... Interesting. So guys... Well, nonetheless, here we go. Steeper slopes of parabolas. So we've talked about the classic up 1, right, for our slopes, right? Up 1 over 1, up 3 over 1, up 5 over 1, right? We've talked about those consecutive odd numbers for our parabolas. But it turns out when the a is different, what you're going to have to do is multiply your slopes by that a number. So it's going to be a times 1. And so check out this graph. This graph appears to be going up 2 over 1, because this is where 1 is. All right. Up, let's see, 1, 2, 3, 4, 5, 6, over 1. Don't be fooled by that horizontal grid. Yeah. And up, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 1. What? So the slopes here were up 2 over 1, up 6 over 1, up 10 over 1. So my question for you is, what did I have to multiply these by to get 2, 6, and 10 for the rises? Right? 1 times what is 2, 3 times what is 6, and 5 times what would be 10. Yeah. So this graph that we're looking at would actually be the graph f of x equals 2x squared. All right? Its vertex was at 0. So that's why it's got a plus 0 or nothing written. And the 2 ends up changing our slopes to being up 2 over 1, 6 over 1, and 10 over 1. And it's just like that. That's all you've got to do. And so check this out. Here is a Desmos graph that I've got here, in which I can actually change the value of a. So notice here, right now, it's the classic up 1 over 1, up 3 over 1, up 5 over 1, up 7 over 1. And if I change a to 2, let's say, there we go. Now it's up 2, up 6, up 10, What's the next up going to be by? Let's see, this would have been 1, 3, 5, 7. What's, so double 7, that would be up 14. Yeah, 14 is what that's going up by. All right, so changing the a value will change the shape of your graph. What about when a is 3? So 1 times 3 is going now up 3. The up 3 is now going up 3 times 3, which is up 9. And the up 5 is now going up 5 times 3, which is 15, right? It's going from 12 to 27, which is up 15. All right, so those rises are all being multiplied by the a value is what happens there, okay? And then the same thing for different values. And I can also have like decimal amounts, right? 1.5, so it's going up 1.5 over 1, and then up whatever 3 times 1.5 is 3, 4.5? Yeah, 4.5 over 1, and then whatever 5 times that would be 5 plus 7.5 over 1. So yeah, so it is possible to do that. And then, like we said earlier, when a is less than 1, it's going to be a vertical smoosh, and you can actually start seeing how this parabola is smooshed down a bit, and that changes your slopes as well. So this would be now up 0.4 over 1. So up 0.4 over 1, up whatever 3 times 0.4 is. So 1.2 over 1, and then whatever 5 times 0.4 is. So that's up 5 plus 2, 7. Oh, so that's exactly going up 7. No. No, it is not. Wait a minute. 0.4. So sorry, this is going up. What did I do wrong, friends? I zoomed in. Wait a minute. Okay, so up 0.4 over 1. Up 3 times 0.4, which was up 1.2. And then up 5 times 0.4. Sorry. Oh, okay. How did I do? Oh, because I did 5 times 1.4, not 5 times 0.4. So this is going up 5 times 0.4, which is exactly 2 units. Yeah. All right. So yeah, so even for decimal values, it works. And what about this plus c thing? What did the plus c do yesterday? What did we discover about that? Plus c just is your vertical shifter, right, for your vertex. And the plus c does not change the shape of the graph at all, even if the shape was stretched. So watch, if this is 2, like so, imagine really hard, there we go, and then I add c to it. Notice the shape of my graph is not changing, just the location, okay? So yeah, so what I will do when I graph these by myself without using Desmos is I'm going to find my vertex, right, wherever that might be, so let's say 3, and then I'll move by my slopes, in this case being up 2 over 1, up 6 over 1, up 10 over 1, and that's how I'll be able to generate my graph. So let's do one of these problemas, mis amigos. This is example 2 from 8.1, technically. Yeah, so Mr. Waddy's all out of order. No, you are out of order. Okay, here we go. So, let's graph 2x squared. So, we actually just did that one, but that's fine. So, my slopes are going to be 2 times 1 over 1, 2 times 3 over 1, and 2 times 5 over 1, etc. Right? And those numbers are actually 2 over 1, 6 over 1, and 10 over 1. I'll have to come up with a different example next time. What's the vertex for this one? Well, C is 0. There's a plus 0 here. So the vertex is going to be 0, 0 for the vertex. 0, 0. All right. And then once I know my slopes, I just move by my slopes. So up 2 and over 1, up 6. I lost count already. 1, 2, 3, 4, 5, 6. And over 1, up 10. And having fun. I think I went up 10 and over 1. We can graph parabolas, right? So this is up 2, 6, and 10. Did I do the 10 right? Yep. And, oh no, I did the 10 wrong. I was short 1. Right, because this was at 8, and so I should have been all the way up to 18. Ah, well, that's the life, Mr. Waddy. Okay, and let's mirror those up to backwards 1, up 6, backwards 1, and then up 10, backwards 1. And there we go. So let's draw this parabola, and I'm going to do my rotate the world. Sometimes life is easier when you turn the world on its head. Parabolas, you turn my world upside down. Yeah. And you guys can turn your papers upside down. I don't know if you knew that. This new paper that I made, it can be turned upside down. Did you know that, guys? It's pretty amazing. It's paper 2.0. You can rotate it on your desk, if that helps you. So there's our parabola. Right, super quick, way better than making a table of values. As far as comparing it to the graph of that, it was a vertical stretch by 2. Vert stretch by 2, right? So let's get to some of these more interessante problems. Interessante. All right. Ooh. Oh wow. We are jumping right into this, aren't we? Wow. I have no intermediary. Okay. Here we go. Because I'm pulling from multiple sections. I know it's crazy. This Mr. Waddy guy is a crazy fellow. I didn't like the way your book taught this to you, nor the order in which it taught it to you. So that's what I'm working on here. So let's see, vertex for this one, there's plus 0. So the vertex is going to be 0, 0. Right? My slopes, this is going to be interesting. And this is where I'm going to have to caution you. All right? So I'm going to do negative 1/3 multiplied by 1 over 1. I'm only multiplying the rise by this negative 1/3. Okay, so watch me very carefully. And I'm not going to reduce this fraction because parabolas don't work that way. Lines do. What's up? Yeah. Yep. No, I know you love algebra a lot, but... Well, here, for sake of time, I've got to keep moving on. So guys, check this out. I'm just simplifying these numerators, which are my rises. So negative 1/3 times 1 is negative 1/3. So I'm going to view this as going down 1/3 over 1, which is not the same, not equal to going down 1 over 3. I'll show you on the graph in a minute. All right, this one, 3 and 3 cancel out, so this will be going down. I could call that 3/3 over 1, or I could say down 1 over 1. I'm going to actually leave that as 3/3, and this one I'm going to call going down 5/3 over 1. Now, I'm intentionally keeping these in these weird fraction forms, because watch what I'm going to do. Now, my y scale here is counting by ones, right? 1, 2, 3, 4, 5. To go down 1/3 would be about there. I'm actually going to change my y scale. Oh, man. My throat is hurting. There we go. By adding 2 tick marks between each of these. So I'm going to split these into thirds. And this will make your graphing oh so beautiful. So add these tick marks. So I'm dividing each one whole unit into 1, 2, 3 units. Okay? And I'm counting by thirds. So now when I move by my slope, I'm going to go down one of those thirds and over 1. Right there. Then I'm going to go down 3 of those thirds. So that's 1, 2, 3 thirds, and over 1. And then I'm going to go down 5 of those third tick marks, all right? 1, 2, 3, 4, 5, and over 1. And that one actually landed on the normal grid. So if I change my scale to match this fraction, count by thirds, I'll actually be able to graph way easier as a result. And all of the grids that I gave you kind of conveniently had those dimensions, okay? And then let's mirror these. Down a third, backwards 1, down 3 thirds, backwards 1, and down 5 thirds, backwards 1. Okay, so let's draw this parabola. And this is a upside down vertical smoosh parabola that we end up having. That's sad, I missed my points, but that's fine. So this is upside down vertical smoosh. It doesn't look that smooshed because I changed the Y scale. Notice my Y scale is all stretched out, that these are not squares, these are rectangles. So I've stretched the image to allow myself to graph better, more easily. Now, what did I want to point out? Okay, other ways of thinking about this. This down 3 thirds, I said would be the same as going down 1 over 1. And notice this is going down 1 full unit. Okay, I went from negative a third to negative 1 and a third. I did go down 1. All right, but counting those tick marks is easier if you leave that in terms of 3 thirds. The other thing I wanted to say was that this is not equal, I said, not equal to the same as going down 1 over 3. This fraction is the same as that, but this will not be my slope. If I went down from this point, down 1 and over 3, this would have been my first point and not this. So this would not work. So Mr. Waddy's slope trick will not work if you reduce, quote-unquote, these slopes. You're only simplifying or dealing with the rises. The overrun is always 1. Okay? So just one of the things to be aware of when you're dealing with fractions. So let's get some plus C going here. Yeah, I'm going to skip a few of those, Plus C's, plus C. Here we go. And this might be the last example of today. So then you guys can have a bunch of practice yourselves. Here we go. So I've given you guys a graph for this example 2, which is 8.2's example 2. Yeah, Mr. Waddy is a little funny in this section. A little bit weird. That's okay. Here we go. So notice I've completely changed this scale. All right. Oh, wow, there are actually like little barely visible tick marks here. Let me see if I can, if I don't shrink this, yeah, I can see those tick marks better. See those? I've got the grid on mine. You might be able to see them better on yours, on your paper there. Okay, so question, this plus 1, what does this plus 1 do? It's a vertical shift up 1, all right? Making my vertex 0, 1. All right, so I'm going to plot the point 0, 1 right there, like so. Now my slopes, which are not really slopes, I'm just putting those in quotes, are going to be changed by this 4 here, right? So this is going to be going up 4 times 1 over 1, up 4... I don't remember. I think we did it. Oh, example 3 from 8.1. And this should be a little bit later on. I skipped some problems, which you can go back and practice on your own if you'd like. Let's see, 4 times 1. So my slope is going to go up 4 over 1. Up 4 times 3 is 12. So up 12 over 1. And then 4 times 5 is 20. Over 1. So this 4 is a vertical stretch, stretch by 4. which you guys do eventually want the skill of being able to determine what your graph looks like. Okay, because this 4 was positive, I knew that it was going to open up. I knew the +1 was going to shift my vertex up, and that vertical stretch by 4, I was like, I need to give myself lots of space for a very steep parabola here. This is going to be gaining ground fast. All right, so watch us graph this. So up 4/1 from the vertex. So 1 + 4 brings me right to the 5. And it looks like my horizontal axis is right there. Yeah. So there's up 4/1. Now up 12/1. 5 + 12 is going to be 17 is where I'm landing. So up 12/1. This is 4. This is 12. And now I'm going up 20. And 17 + 20 is going to be 37. Conveniently. Barely enough space for that. Which my general rule for parabolas is you want to have 5 points to plot your parabola. At least 5. So let's see. Let's mirror this. Let's mirror this point over to here. Yep. And mirror this one over to here. Okay? And now we can draw this lovely parabola, and we didn't need to do any table of values. Flip the world on its head. You think I can't, I just did it. And so this is going to be like a skinny parabola because it's been stretched out like bubble gum. I will. And like so. That actually works pretty efficiently. All right, so yeah, so thank you for watching, internet friends. Have a great day. Bye-bye.